Welcome to Chapter 8. In this chapter, we're going to learn a lot about functions, graphing functions, linear functions, nonlinear functions, and just practice working with functions in general. Okay, on this first section in 8.1, we're going to focus on linear functions. That is, functions whose graphs form a line. Okay, so we're going to start by just graphing two linear functions. A simple way to graph linear functions, well, to graph any functions really, is to make a table of values. I typically call this a T-chart because it looks like a T here, except we're going to do a double T and put 3 columns, one for f of x and one for g of x. So those are two different functions, and we're going to go ahead and graph both of them on the same graph or on the same set of axes over here. Okay, so we're going to do these by just plotting points, and then we'll talk more about how to graph lines without plotting points. So what I'm going to do is choose a few different x values and then compute these corresponding y values. So let's start in the negatives. Let's start with -4. We'll skip -3. We'll do -2. How about 0, 2, and 4? And that should be enough points to get our lines. Now you really only need 2 points to draw a line. I'd say to do 3 to just make sure and double check yourself. We're going to do a few extra in this case. Now if f of x is equal to 3 times x, if x is -4, you'd have 3 times -4 or -12. If x was -2, 3 times -2 is -6. 3 times 0 is 0, 3 times 2 is +6, and 3 times 4 is +12. Okay, so if you'll notice, these tick marks here don't actually go out to 12, so I'm not actually going to plot this first point and this last point if I go by ones, and that's what I'd like to do here, is to just go by simply ones. So I'm going to let each tick mark here represent 1. So when x is -2, y is -6. So this line, f of x, goes through that point, -2, -6. It also goes through the point 0, 0, and it goes through the point 2, 6. Which is way up here. Okay, from here we can draw in the rest of the points because f is of course defined for all real numbers. You can plug any decimal or fraction in, but all those points that you plug in will fall on this line here. Now your line should look straighter than mine because you're drawing with a pencil and paper. It's a little easier to do. That should be a straight line, and there is the graph of f of x equals 3 times x. Okay, now what I want to do is look at how the graph of g of x differs. Well, it's 3x minus 4 is how it's defined. So it's the same as f of x except 4 less for all the y values. So if x is -4, you'd have 3 times -4, which is -12, minus 4, so -16. If x is -2, you'd have 3 times -2 or -6 minus 4 is -10. Unfortunately, we're still not on this particular set of axes because my y values here only go from -6 to 6. So these were not very good points to choose for this, and sometimes that's going to happen to you too. If x is 0, we'll have -4. If x is 2, we'll end up with 2, and if x is 4, we will end up with 8. Now 8 is close enough that we can just go ahead and draw it because it's only 1 unit off the graph. Okay, so at least I have 4 points here that are on the graph. When x is 0, y is -4. So it goes through this point right here, 0, -4. I like to label at least the important points, so that's -4 there. It goes through the point 2, 2, and it goes through the point 4, 8. about right there. And so if you were to plot all those other points in between all those other decimal numbers, it would look basically like that. So here's the graph of g of x, which is defined by 3x minus 4. Okay, so what I want you to notice here is that all the y values are the same between f and g. It's just that g of x is literally shifted down 4 units. See how that y value went down 4 units? Here's another y value. It went straight down 4 units. All of these y values go straight down 4 units. Okay, if it was drawn perfectly. And that's the difference between f and g. So that's one way to graph functions. Okay, now let's review and learn a little bit more about how do you graph them without making a t-chart. Okay, there's what's called a slope-intercept form of an equation. And there are many forms of linear equations. Slope-intercept is probably the most commonly used. And it looks like this. Y equals mx plus b. That's called slope-intercept form because m represents the slope. We'll talk about that in a moment. X is the variable, and b is actually your y-intercept. So the point 0, comma b is the y-intercept. And let's scroll back up and look at this graph that we just did. Okay, in this one, see, m here is the coefficient of x, and it's called the slope. It refers to the steepness of the line. So on both f of x and g of x, the coefficient of x here is 3. So the slope of both of these functions is 3 because that's the coefficient of x. And if you'll notice, they both have the same steepness. Okay, and what slope represents is rise over run. Okay, let's review that over here. The slope, which is rise over run. So up here, where the slope is 3 on both of these, you might want to think of it as 3 over 1 if you're going to think of it in terms of rise over run. So what that means is you can choose any point on the line. I'm going to go with 0, 0. And you rise 3 points. So you go, because this is positive 3, we'll go up. So we'll go up 1, 2, 3. And then the run refers to how far you go to the left or right. This is positive 1, so we go to the right 1 unit. And there we are at the next point on the line. And then from there we can go up 3 over 1. And we have the next point. So that refers to how many points up or down, and then how many points to the left or right you go to get to the next point, where right is positive and left is negative. Okay, 0, comma b is the y-intercept if it's in the form mx plus b, as both of these up here are. Now in this case, for f of x, we have 3x, and there is no plus b, which means b is 0. Okay, so on f of x equals 3x, that's the same as 3x plus 0, so the y-intercept is 0. As you can see that too, because it crosses the y-axis at 0. And then on g, the y-intercept is at negative 4. So the y-intercept is negative 4. And here it is. It crosses the y-axis at negative 4. So you can figure out where exactly it crosses the y-axis just by looking at this last term, the constant that's added on to the x term, and you can figure out where it crosses the y-axis from that if it's in slope-intercept form. So a linear function, as opposed to a linear equation, is a function that can be written in the form f of x equals mx plus b, or f or g or whatever the function name is. But the point is you have a function name instead of y is equal to mx plus b. Okay, so if we were to write it like that, this is just what I said previously, g of x equals 3x minus 4, that's the example we just did, has the slope 3 and y-intercept negative 4 because it is a linear function. So let's do a little bit more work with linear functions here. Let's graph these two linear functions on the same set of axes. Now this time I'm not going to plot points. This time I'm going to do it by using information about the slope and the y-intercept. So first let's graph f of x equals negative 1/2 x. Now for f of x, we want to find the slope and the y-intercept. So the slope is the coefficient right here of x, which in this case is -1/2. Now you have to put that negative either up in the numerator or in the denominator. It doesn't matter which, if you're going to think of it as rise over run. So I'm going to choose to put it in the numerator. And the y-intercept, b, is 0 because we have -1/2x plus 0. So we know this graph crosses the y-axis at 0, and then to get to the next point we can use the slope. You go rise over run, so down 1, right 2. So go down 1, right 2. And that's another point on the line. Down 1, right 2. We get another point. Now if I had put this negative here in the denominator and said it's +1 and -2, then that would mean rise is up 1. So I'm going to go back to 0, 0, go up 1. And then the -2 means left 2. So we go up 1, left 2. So see how it still gives us points on the line in that same direction. So if we just fill in those gaps in there, here's the graph of f of x. And we didn't plot a single point. All we did was use the y-intercept and slope. And now let's graph g of x. G of x is defined by -1/2 x plus 3. So let's see, it has the same slope, so it's going to have the same steepness to it, down 1 over 2, but it has a y-intercept of 3. So it crosses the y-axis up here at 3, and then from here we'd go down 1 over 2, down 1 over 2, and in both directions. So here's the graph of g of x. Okay, so now that you have the basics down, let's do a few more examples. So to write a linear function, what that means if you're writing a linear function is to write the equation for the line whose graph passes the vertical line test. So a function is just, or linear function is just a linear equation that is also a function. Okay, so what I said is to write a linear function means to write the equation for a line whose graph passes the vertical line test. We're going to do several of those too. Now, before we go on too much to functions, we do need to review different types or different forms of the equation of a line. So the only one we've worked with so far here is the slope-intercept form, where m is the slope and 0, b is the y-intercept. Okay, another form, which is also, it's the same thing, but it just written differently, looks like this. It's called point-slope form. M is the same thing. M is still the slope. But in this form, the coordinates x1, y1 represent any point on the line. We'll do some examples like that. Now sometimes you'll have an equation of the line that's very simple. It'll just say, for example, y equals c, y equals a number. In that case, you have a horizontal line. Horizontal lines have a slope of 0 because the rise over run, the rise is 0, and the y-intercept is simply that c value, which you'll see when we graph them. Okay, standard form has really no practical uses, at least in this class. And in college algebra there are no practical uses, so it's not used very commonly, but you will sometimes see functions or equations written in this form. A, B, and C are just numbers. They actually have no meaning. And then the one other form of a line is a vertical line, so as opposed to a horizontal line. Now vertical lines have an interesting equation, and that is x equals some constant c. Vertical lines actually have no slope. The slope is undefined. You'll see why, what happens when we try to find the slope later. And the x-intercept is c. Now, they typically don't have a y-intercept unless they are equivalent to the y-axis. Okay, so we're going to work with several examples of each of these here. First, we want to write the equation of a line with slope -2 and y-intercept 0, 3/4. And then we'll write the equation using function notation. So first we'll just worry about writing the equation, and then the last thing we'll do is worry about function notation. Okay, so in this example, we are given slope and y-intercept. Now you can choose to use any of these forms of the line, any of them that work. It has a slope. The slope is not 0 and it's not undefined. So it's not a horizontal or vertical line. But we can choose any 3 of the other forms: standard form, point slope form, or slope intercept form. And the one you choose should depend on what you're given. Okay, in this example we're given slope and y-intercept. So if you look at these 3 forms, which one uses the slope and the y-intercept? Well, it's the one we've been using. Slope-intercept form uses the slope and the y-intercept. So that would be the best version to go with here. So first I'm just going to write the general form of the line. We know that the general form of the line is mx plus b equals y. And in this case we know the slope is -2. So that tells us that m is -2. And the y-intercept is 0, 3/4, which tells us that b is 3/4. So the equation of the line, we just fill that in, is -2x plus 3/4. Now that's it. And now to write it in function notation, we can just rewrite y as f of x or g of x or h of x. So there it is in function notation. Let's do another example. Let's write the equation of a line that goes through the points 3, 0 and -2, 4. And we'll write the equation using function notation. Well, this is different. We're given 2 points on the line, so that makes it a little bit more challenging. Point slope form might make sense because it uses a point on the line. However, no matter which form we choose, slope, intercept, or point slope form, we're going to need m, the slope, because they both use m. So before we can do anything else, we need to find the slope. Okay, the other way to find the slope, as opposed to just rise over run, is to find it through 2 points. You use this, y2 minus y1 over x2 minus x1. That is the slope of the line that goes through the points x1, y1 and x2, y2. So if those are 2 general points, this will tell you the slope of the line through those 2 points. In other words, it's change in the y values divided by the change in the x values. So if you're given 2 points, you can use this to find the slope. Well, you just have to choose to call one of the points x1, y1. I'm just going to go with the first one for that. And we'll call the other point x2, y2. Okay, so plugging it into that, we'll have m equals y2, which is 4, minus y1, which is 0, divided by x2, which is -2, minus x1, which is 3. Be real careful with your negative signs on these things. So in this case, we get 4 divided by -5, or -4/5 as the slope. Okay, that's good because regardless of which form we use, we need the slope. So now let's go look. We have 2 forms. We have slope-intercept form and the point-slope form that are the 2 reasonable forms to choose from because slope is not 0 or undefined and standard form is useless. So the question is, which one do you want to go with? Well, we don't know the y-intercept. So I'm going to recommend that we go with point-slope form because we do know a point on the line. In fact, we know 2 points on the line. Okay, and I recommend that you actually use point slope form as much as you can, because it's going to come in handy when you get to calculus. You're primarily going to use point slope form when you're talking about lines in that class. So let's go with point slope form. I'm going to start by writing the general form of it, which you need to have memorized. Y minus y1 equals the slope times x minus x1. Now technically we can use either of these 2 points, even though I previously had labeled the first point as x1, y1. Either of these 2 points we can call x1, y1 for this equation of a line. And so I'm going to go with the same one though, 3, 0. And for m, that's negative 4/5. So plugging in, let's see, 0 for y1, negative 4/5 for m, and 3 for x1 gives us that. Now this is good. It is an equation. We can simplify it a little bit and rewrite it using function notation. Now to put something in function notation, you must solve for y. Okay, that's the only way to write it in function notation, is to first solve for y. Well, that's actually easy. It is solve for y because y minus 0 is just y. So in function notation, this would say f of x equals negative 4/5 times x minus 3. And that is a perfectly good answer. A lot of students have the tendency to want to always expand. There's really absolutely no reason to expand that negative 4/5 out here, because you have a perfectly good answer at this step, and we don't need the y-intercept because we're not graphing it or anything like that. So I would just stick with this form right here. Okay, let's do another example. Let's write the equation of the horizontal line containing the point negative 1/6 and use function notation. So horizontal lines have the form, you'll need to memorize this, y equals a constant, where that y-intercept is the constant and the slope is 0. So we already know that the line's going to be of the form y equals c. Something like that, where c is the y-intercept. Now at this point we don't know the y-intercept. It's kind of hard to know what that constant there should be. So let's start by plotting the point that we know we want it to go through. Let's see, we know we want it to go through the point negative 1, 6, which is way up there. Negative 1, 1, 2, 3, 4, 5, 6. And we want it to be horizontal, so I can go ahead and draw it in. It's going to look like this. Okay, now the constant c, remember, that is the y-intercept, and here's the y-intercept right there. That's where it crosses the x-axis, which is at a value of 6. So the equation of the line then is y equals 6. In function notation, it would just say f of x equals 6. It's a very simple equation because essentially no matter what x is, if x is 2, y is still 6. If x is negative 5, y is still 6. If x is 0, y is 6. Doesn't matter what x is, y is always equal to 6 on this horizontal line. So that's why it is the equation for such a horizontal line. Okay, let's look at a vertical line. Let's find the equation of a vertical line containing the point negative 1, 6. So same point, I want it to go through this point right here, negative 1, 6, but I want it to be vertical instead. So it's going to go like that. Okay, vertical lines, going back up in our notes, have the form x equals c. The slope is undefined, we'll look at y now, and the x-intercept is that c. So what is the x-intercept in this case? Well, that's where it crosses the x-axis. That's right there, and that's at x equals negative 1. And so that is the equation of this line, x equals negative 1. And that's because no matter what y is, if y is 0, if y is 4, if y is negative 6, x is always equal to negative 1. Okay? Now notice this one does not say to use function notation. That's because this is not a function. It does not pass the vertical line test. So if you imagine your pencil right here and you're sliding your pencil across the x-axis in this direction, Boom, right here. You hit a vertical line. You have infinitely many points touching your pencil at once. So this is not a function. And because it's not a function, there's no way to write it as y equals something. And so we can't write it in function notation. Now let's look at the slope. Slope, remember, is rise over run, or if we have 2 points, it's y2 minus y1 over x2 minus x1. So let's choose 2 points on this line. Let's go with -1, 6 for x1, y1. And let's just go with this x-intercept here, which is the point -1, 0 for x2, y2. So if we use those 2 points to compute the slope, we'd have y2, which is 0, minus y1, which is 6, over x2, which is -1, minus x1, -1. So yeah, be aware you have a double negative there. So we get -6 divided by, this is -1 plus 1, which is 0. And there's the problem right there. You can't divide by 0. And so the slope, this number, is undefined. Okay, so this actually has no slope, or an undefined slope. Let's look at parallel and perpendicular lines. Parallel lines look like the ones we drew up here at the beginning. These two lines are parallel because if you drew them out infinitely long, they'll never cross. And notice they have the same slope, -1/2 and -1/2. The same thing is true up here. We have, although it doesn't look like it because my drawing is off down here, these are supposed to be two parallel lines. They both have, again, the same slope, 3 and 3. And that's the key thing about parallel lines, is parallel lines have equal slopes. Perpendicular lines are a little different, so we'll come back to that in a moment. First, let's do this example. Let's write the equation of a line containing the point -1, 2, and that is parallel to the line 3x plus y equals 5. And we'll write the equation in standard form rather than in slope-intercept or point slope form. So let's start with what we know. We know it goes through the point -1, 2, okay, and it's parallel to this line. We're going to have to use the fact that it's parallel to this line to tell us something. Now, if it's parallel to that line, that tells us that the two lines have equal slopes. So we need the slope of this line. Now, just because we have a 3x, a 3 in front of the x here, does not mean the slope is 3. Point slope form, slope-intercept form, that y equals mx plus b up here, has to be solved for y in order for m to be the slope. So in order to figure out what the slope of this is, we're going to have to solve it for y. So if we subtract 3x from both sides, we'll have y equals -3x plus 5. Now it's in slope-intercept form, y equals mx plus b. So the slope is the coefficient of that x, which is -3. Okay, so slope is -3. And because we want our line to be parallel to that, the slope of our line is also going to be -3. Okay, so we have the slope, and the other thing we have is a point. Okay, at this point we have the slope and we have a point. So I would go with point-slope form because that's what we have. So point-slope form is y minus y1 equals the slope times x minus x1. If you just write this every time you do a problem, you'll have it memorized in no time. So we know m is -3, and this I'm going to call x1, y1. So we have y minus y1, which is 2, equals the slope, which is -3, times x minus x1, which is -1. Simplifying this, we get y minus 2 equals -3 times x plus 1. Okay, so there's the equation. Now we just need to write it in standard form. So let's go review what standard form was. Standard form up here was ax plus by equals c. So we had the x term and the y term on one side and a constant on the other side. So let's see if we can put the x term and the y term on the same side of the equation. Let's see, the y term is on the left, and before we can move the x term over, we're going to have to distribute out that negative 3. So this becomes negative 3x minus 3. So I'm going to move the 3x over to this side, and I'm going to move this negative 2 over to that side so that the x and y term will be on one side and all the constants on the other side. So adding 3x to both sides gives me 3x, then we have this plus y, is equal to, then we have negative 3 plus 2, which is negative 1. So there it is in standard form. Okay, and let's quickly graph. If you graph each of your equations, you should be able to figure out pretty quickly if they are or are not in fact parallel. Now, in order to graph this, I'm going to put it in slope-intercept form by subtracting 3x from both sides so that I can just quickly sketch a graph by looking at the slope and the y-intercept. And for this one, I can tell it goes through the point 0, 5. 1, 2, 3, 4, 5. There it is. And the slope is negative 3, which is negative 3 over 1. So down 3, right 1. Down 3, right 1. So here is the equation, or the graph of the original line. That's not our line. This is the graph of 3x plus y equals 5. Now I'm going to graph our line, which I'll do in orange. 3x plus y equals negative 1. So to graph it, again, I'm going to solve for y. That's y equals negative 3x minus 1. So it's a slope of y-intercept of negative 1. And the same slope, down 3, right 1. Down 3, right 1. Or up 3, left 1. Up 3, left 1. And as you can see, it does appear that they are, in fact, parallel. So there is the graph of 3x plus y equals negative 1. And I should mention at this point, make sure you always label your graphs with their equation. That way we know which is which. Okay, the next example involves perpendicular lines. So let's go back up here to talk about perpendicular lines first. Perpendicular lines have slopes that are related, but they're not the same. They have slopes that are negative reciprocals. You'll see why it works once we graph the functions on this next example. Their slopes are negative reciprocals. So, for example, the two numbers 4/7 and negative 7 over 4 are negative reciprocals. They're reciprocals because one is upside down from the other, and they're negatives because one is negative and one is positive. So another example would be 3 and negative 1/3. If you think of 3 as being 3 over 1, then when you flip 3 over 1, you get 1 over 3, and then one of them would be positive and one negative. So those are negative reciprocals. So what we want to do is write a function that describes the line containing the point 3, 4, and that is perpendicular to the line 2x plus 4y equals 5. And we'll graph both lines. So our function contains this point, 3, 4, and it's perpendicular to this line. So let's handle the perpendicular part first. If it's perpendicular to that line, well, first we need the slope of this line, then we can figure out the slope of our line. So for this line, in order to find the slope, there's a couple ways to do it, but the easiest is just to simply solve for y and then read it off because the slope will be the coefficient of x. So solving this for y, we get 4y equals negative 2x plus 5. And then we divide both sides by 4. Make sure you divide both whole sides by 4 here to get y equals negative 2/4 plus 5 all over 4. I'm going to split that into two fractions, negative 2x over 4 plus 5 over 4. And then we'll simplify from here. Negative 2/4 is the same as negative 1/2. And I'm going to write it with the x out to the side because that's how mx plus b form typically looks. You have a number times x plus a number. So reading off the slope of this, the slope here is negative 1/2. Okay, now that's not the slope of our line because our line is perpendicular to this line. So the slope of our line is its negative reciprocal, which is positive 2 over 1, or just 2. So there's the slope of our line. And again, we know it contains the point 3, 4. So I'm going to go with point slope form. Y minus y1 equals the slope times x minus x1. Here's our m, our slope. Here's our y1, our x1, y1, 3, 4. So we have y minus 4 equals 2 times x minus 3. So there's the equation. Now we just need to write it in whatever form is specified, and it doesn't say what form is specified, but it does say to write a function, meaning we're going to have to solve for y and then replace y by f of x or something. So let's add 4 to both sides, and then replace y by f of x, and here it is add as a function. Okay, now in this form it's a little difficult to draw at this point because we can't read off any information about it until we put it in slope-intercept form. So the only reason I'm going to expand this 2 out is for graphing purposes. So for graphing purposes, this is the same as f of x equals 2x minus 6 plus 4. Combining like terms, that gives us 2x minus 2. So let's graph f of x equals 2x minus 2. So it has a y-intercept of negative 2 and a slope of positive 2, which would be slope of 2 over 1. That's your rise over your run. So I'm going to go up 2, right 1. So up 2, right 1 to get to the next point, and just draw in several points like that. Okay, so there's the slope of our line. Now let's graph this other line. I'm going to graph it from this equation right here. This is going to be slightly difficult because we're graphing fractions, but we can do it. 5/4 is just a little bit over 1, which is its y-intercept. And then the slope is negative 1/2. So down 1, right 2. Down 1, right 2 would be just about there. Down 1, right 2. What I'm looking at is, I'm trying to see is, do these look perpendicular? They should. So if we fill this in, it appears to me that they do make a right angle. They look perpendicular to me. Now, of course, they're only going to look perpendicular if your grid is square, otherwise they won't. So if you graph these two things on your calculator, if you have a graphing calculator, at first they actually will not appear perpendicular, and that's because the standard window for a graphing calculator is not squared. One axis is longer than the other. So you can square it by going to zoom square, and then they'll look perpendicular, but until then it'll look a little off. So there it is. There's our function, and it is perpendicular to the original line. So that's it for lines, and then in section 8.2 and in 8.3 we're going to graph nonlinear functions, things like absolute values, squares, square roots. Those are fun. And then we'll learn about piecewise functions as well.